This video is sponsored by Justway. Hello there and welcome back to another video. Now, back right at the end of December last year, I posted a video about a project that ended up garnering a ton of traction. So much so that I got a ton of views considering what my channel usually gets, a ton of views of the project on Instructables, a Hackaday article was written about this, and with this project, I managed to win a big prize in the Instructables Anything Goes contest. So, needless to say, people thought this project was cool, and I also think that it was really cool. Now, for those of you who don't know what project this is my DIY per application volume mixer for a PC that, in particular, has motorized faders so that you can store and recall different mix presets. Basically, with this device, you could bind YouTube to a fader, Spotify to another, your games to a third, Discord to a fourth, and your main output level or something to the fifth. Then you could use the faders to control the level of each app individually, and you could store up to 5 custom preset mixes of these apps and the main output level, and then you could just recall those 5 mixes at the press of a single button and overwrite to store another one with the press of 2. This thing worked great, and I think it was an amazing project, especially considering that it's the first project like this that I've seen that uses motorized faders. However, as cool as this thing is, there's always room for improvement. Namely, I wasn't too happy with how the fader movement was at the end of the project because they were slow, moved one fader in one direction at a time, and they also weren't very accurate either. And people in the comments not only agreed with that at times, but they also had a bunch of other great ideas on features to add and ways to improve the existing user interface, as well as the ease of assembly. And so, I'm back, this time with a V2. Because what if you could store the presets by holding the preset button and recall them by short pressing it, instead of having to have a dedicated store button? And what if the faders moved like they did on a real console with PID motor control, so they move fast, accurate, and all at once? Then what if there were scribble strips for all the faders so that you can label them easily as well as see their level as a percentage? And what if I add some mute buttons to each fader where the preset buttons are currently, and then move the preset buttons to be in a column along the side, and add a few more presets while I'm at it? Plus, what if there was an extra knob that could be dedicated to master volume or something so that all 5 faders can be free for mixing your apps while not having to give up your physical main output control? Also, I've got to be honest, I'm not vibing with the cheese wedge form factor anymore. That's gotta go. And with all of that in mind, I really think that this V2 is gonna come out good. And let me tell you, it sure did. But wait, stop looking. You gotta get through the build process first if you want to see the final result. So let's get started on that. The first step to get V2 on the road was making a CAD model for it. And I ended up doing this over the span of a few days in Fusion 360. I ended up modeling the new version with a body shape pretty similar to the mixing console that I bought for personal use and practice around the same time I designed this. That console being the PreSonus Studio Live 32SC. I also took a bit of a page out of the Yamaha DM3's books and was originally going to lean even more towards this body shape with the flat surface for the faders, but in the end, I figured that a slight slant like on the 32SC would be more ergonomic for use when sitting at a desk instead of standing at a front of house tech table. I then included 8 buttons to store, you guessed it, 8 preset mixes instead of 5 along the right hand side, and above each fader is a nice, big illuminated button that latches for muting each channel. And this will work really seamlessly, I think, because MIDI Mixer has mute functionality built in already, so it should be super seamless to implement. Then the last part on the main section of the control surface is the set of 5 Behringer X32 replacement motor faders, which remain basically unchanged when compared to the previous design because they are still the cheapest source of motor faders that I've found. There are a few differences with the way that they're implemented though, namely that the distance between the faders is a little bit larger than on the previous model due to the width of the screens used for the scribble strips. And then of course, the motor driving circuitry behind the motors in these faders has been completely overhauled for better control. But for overall use, the fader parts themselves are the same, and so are the fader caps, and they'll behave the same way when you're using them to mix the apps. And now I come to the smaller panel that's at a steeper angle at the top of the mixer. This is where one of my favorite ideas that was suggested in the comments of the previous video is, scribble strips. This panel has 5 128 by 64 I2C OLED displays on it, one for each fader, that allow you to display a custom name for each fader, and they'll also display the mute status of the channel, as well as the fader's current level as a percentage out of 100. Finally, in the top right corner of the control surface, there's a regular old knob, which was honestly put in as a bit of an afterthought just to fill the dead space there, but I think it's a great knob to bind to your master volume, so that you can have all 5 faders for other purposes while not having to give up your physical control for your master output volume. Now, as for the more technical level of how this system works, I still have it running using MIDI Mixer as the software on the computer, though it's technically compatible with anything you can code an Arduino board to be compatible with. But for now, this means that it runs on MIDI and just sends basic MIDI commands to the computer. So you could also probably interface this thing with some other software if you wanted to, without actually having to change anything about the firmware. Alright, enough rambling about the model. Let's get to prototyping because I need to test some stuff before I pull the trigger on the custom manufactured parts. And the first part that I prototyped was the small panel with the 5 OLED displays. This is because this panel uses a bit of an unconventional way to mount the displays to it, mostly for the sake of aesthetics. The displays end up screwed to a backplate piece, and then the backplate is mounted to the front panel. I did this so that I could avoid all of the ugly screw heads for each of the 5 OLED displays being visible from the front, as the displays are not centered in relation to the screw holes, which bugs me an unreasonable amount, and also having a bunch of M2 screw heads, like 20 of them, so densely packed together in one small area of the panel would almost certainly not look great. Of course, this results in a pretty precise CNC'd front plate that I need to test by 3D printing it before I order it to make sure everything fits. And thankfully, after only a couple minor revisions, I had a prototype of this assembly that had a beautiful fitment and that I was confident would work out the way I wanted it to once it was made out of aluminum. Also, I printed a sliver of the main control surface plate and double checked the fader mounting as well as the mute button holes, even though I was very confident that they'd be fine because I'd made panels for these exact faders before and the button holes are literally circles, but it's better to be safe than sorry, especially when you're machining stuff out of aluminum where it will take a lot of time and cost a fair bit of money to redo it if you mess up. But now that I was happy with the physical prototyping, I moved on to some of the electronics prototyping before I got a custom circuit board made for this project. And the main thing that I wanted to mess with here was the new motor control circuitry, as that's what's really been changed this time around. The previous design used L293D motor drivers because they're simple, cheap, and reliable. The issue is they kinda suck because they're BJT based. So for this version, I switched to using DRV8833 modules, as these drivers can handle a lot more current than an L293D, are still cheap and easy to use, and most of all, they're based on FETs instead of BJTs, which means they're better for motor braking and quickly reversing the movement direction to kill the motor's inertia, which will be very important for fast and accurate motor movement. These drivers will then be paired with an upgraded Teensy 4.1 microcontroller, which, while being about $30, so $10 more than the Arduino Micro used in the previous design, it actually has all of the I/O I need, as well as a much faster CPU to handle more features, screens, and most importantly, the fast PID control loop for the motor faders. And making that fast PID control loop is exactly what I got to work on now. And I'll be honest, I'm not smart enough to figure this stuff out on my own currently, and so this part of the program's creation was heavily aided by AI. Not something I'm very proud of, but I knew I needed PID, and I did what I had to get the PID code written without spending weeks getting one fader moving. After several hours of coding and tuning the PID, I was left with something pretty darn promising looking, and it certainly looked a lot better than anything I had got when building the previous version of the project. So, with my PID control circuitry figured out, as well as the important parts of my CAD model test fitted, I placed orders for the custom manufactured parts of this project. And that's where the sponsor of today's video comes in. Justway. Justway is a custom manufacturing company that offers many services, a few of which include CNC machining, 3D printing, and sheet metal fabrication. For this project, I used Justway's CNC machining and 3D printing service, and I had them machine the 2 faceplates of the project out of 6061 aluminum, and I also had them finish those parts with a bead blast and anodized clear finish. Then I also had Justway 3D print the 5 fader caps for this project because while I have a 3D printer to print the main body, I wanted the fader caps to feel really nice and smooth. And for that, I really need to be using a resin printer that I don't have, but Justway does, so I chose to have them 3D print those parts. If you're interested in building or repairing things and find yourself in situations where you need custom parts, maybe made out of a specialty material or manufactured using a special process, I strongly recommend visiting Justway to see what their versatile custom manufacturing services can do for you. Plus, for a limited time, Justway is offering $10 off of orders over $30 to viewers of my channel. All you have to do is use the coupon code that's on screen and in the video description when you're on Justway's website, and you can get this discount. Check Justway and their services out at my referral link in the video description. After a couple weeks had passed, a very exciting package was on my doorstep, and that package contained my 2 custom CNC machined front plates, as well as my resin 3D printed fader caps. And while I was waiting for these parts to arrive, I had also 3D printed the main chassis box on my 3D printer in some black PLA. So now, when adding a custom PCB to the picture, I have all of the parts I need to start building this project. Though, before I do that, I do want to talk a little bit about the CNC'd parts, because the only drawback with these pieces is that while Justway's prices are incredibly reasonable for what you get, that being a professionally manufactured part with tight tolerances and a beautiful surface finish, these CNC'd parts are still more expensive than a 3D printed counterpart. It is metal versus plastic after all. The issue with the first version of this project was that the CNC'd plate was very thin, therefore meaning that getting the part 3D printed, even using the high quality services at a place like Justway, would result in a flimsy feeling final product because in that application, the plastic just wasn't rigid enough. However, I wanted these plates in this version to be easily 3D printable for those who want to shave some of the cost off of the project, even if it comes at the expense of the project's overall feel and aesthetic. So the models for these plates are thicker this time around, and they're thick enough that 3D printing these parts is 100% doable and will result in a good final product still. So just know that you can 3D print these parts if you'd rather do that, though nothing will fully replace the premium feel of the CNC'd plates, at least in my opinion. Alright, let's get building now. The first part of this build process was assembling the custom PCB for the project, which I designed to be pretty easy to assemble, as I purposefully strayed away from using any SMD components. Plus, a lot of the headers for the connections to the buttons, faders, and screens don't even need to have headers soldered to them. That's because this board mounts to the back of the front panel, and therefore, you can just make the connections with small bits of wire and your soldering irons super easily, but we'll get to that in just a bit. So I soldered all of the components to the board and made a few minor mistakes as always. One mistake I made was that I soldered female headers to the connection points for the OLED screens and the knob, but the issue is that once placed in the 3D printed tub to form the whole chassis, there isn't enough clearance for a male to female header connection for these parts, and the wires will instead have to be soldered directly to the PCB. Whoops. Then another mistake that I made that cost me some troubleshooting time later was that when soldering the motor drivers to the board, I forgot to ensure that these little jumpers on the backs of the driver modules were shorted with some solder. If you don't short these out, the boards default to a sleep mode and therefore will never send any signals to the motors. So make sure these are shorted so that the motor drivers drive the motors. Once all of the components were soldered though, even with the minor mistakes I made, I moved on to a pretty important part of the project, setting the voltage of the boost converter on the board. The board is powered by a 9-volt power brick, but annoyingly the LEDs in the mute buttons require 12 volts to light up. So that means that I need a 12-volt rail on the board as well. Therefore, I placed a small boost converter module on the board that you need to set to 12 volts using the onboard potentiometer and provided test points before shorting the plus 12 volt EN header on the board, which actually lets the boost converter's voltage through to the rest of the circuit only after it's been set to 12 volts. And with the board assembled, it's time to move on to working on the main plate, that is, the larger of the two CNC'd parts. We're basically going to mount everything to this plate and then spend a while on the back of the plate wiring everything up to the PCB. Then, once that's done, it'll all drop into the main chassis, and that will basically be the whole build. So I started by mounting the faders using two M3x12 countersunk screws and nuts for each fader. And I made sure to mount the faders so that their motors were at the end closer to the mute buttons. I also made sure that while I tightened the mounting screws down pretty good, I didn't over tighten them, as when building V1, I learned that it's really not hard to tighten the screws enough to deform the fader's frame and cause the motor's pulley to rub against the CNC'd plate. This will result in the fader not moving smoothly, both when you're moving it manually and when you're trying to move it with the motor. Once all 5 faders were mounted to the plate, I moved on to screwing the mute buttons into place. The buttons that I chose come with a nut and an O-ring to mount them to the panel, and I'll be using the included nut on the back to hold each switch in place, though the O-rings aren't needed for this build because it's not really a waterproof or water-resistant device, and they mess up the flush mounting of the buttons if they're used in this case. So after de-O-ringing all 5 buttons, I mounted them to the panel with the included nuts, making sure that they were nice and tight. I also kept all of the buttons terminals facing in the same orientation, just so that the wiring would be cleaner and more consistent later. Next up, I grabbed the 8 preset selection buttons, and just like with the mute buttons, I won't be using the O-rings on these switches either. I mounted them into the holes using their included nuts and made sure all of their terminals were facing in a way that if you drew a line between the two terminals, the line would be perpendicular to the faders. This will make it a lot easier when it comes to wiring up the buttons later. And now it's time to mount the final piece to this panel, the circuit board. The board sits on 4 15mm tall M3 standoffs, which I mounted to the front panel using an additional 4 M3x8 countersunk screws. Then, once the standoffs were mounted to the panel, I dropped the board onto the standoffs on the other side so that the teensy was further from the motors than the motor drivers. And then, I tightened everything down with 4 M3 nuts. After that, I started to make all of the connections between the faders, motors, and buttons, and the main PCB. I won't go into any details about the wiring in this voiceover and YouTube video, and if you're looking for that, go ahead and check out the Instructable in the description, where you'll get full written instructions on how to build this thing. But in any case, the idea of mounting the PCB to the back of the front panel and then making the wiring connections like this was brought up in the comments of the previous version as a way to make the assembly and serviceability of the device easier. And I think that that turned out to be an exceptional idea that I'm really glad I implemented, as now I don't have to try and plug in a bunch of DuPont wires to a board while I'm closing up my window of access to the device. In any case, once the wiring on the back of the main panel was done, I moved on to preparing the 5 OLED displays and the knob by soldering some wires onto them. In this case, I soldered wires that had male DuPont connectors on them, as I thought that I was going to be plugging these into the female headers on the board, but again, I ended up just stripping the ends of the wires and soldering them straight to the PCB in the end. Once the displays and potentiometer were prepped, I mounted the displays to the mounting bracket and then half tightened the mounting bracket to the other CNC plate using the 2 middlemost screws. The other 2 screws on the end that mount the OLED plate to the CNC piece actually double as the screws that hold the whole assembly to the main chassis as well, so those can't be screwed in just yet. So with the 2 main panels ready to go into the chassis, I moved on to the big 3D printed main chassis where I mounted the barrel jack and soldered 2 long wires to it. Then I hot glued the micro USB to female USB-C cable into the 3D printed bracket that holds it in place and mounted that assembly into the case with 2 M3x10 screws and nuts. After that was done, I connected the barrel jack to the main PCB and plugged in the micro USB cable and then tried to plug in all of the OLEDs and mount it all into the chassis. I first found out that I needed to add some extensions to some of the OLED's cables as they wouldn't reach the full distance that they needed to. So, okay, that's fine, did that. And then I realized the pretty serious clearance issues at hand. This resulted in me having to cut all of the DuPont ends off of the OLED wires and the knobs wires, and then I had to solder these wires directly to the pads of the female headers on the PCB, which I also had to remove. So with these connections now directly to the PCB, which added to the complexity of this project, I went back to mounting everything in the case, only to find out that the clearance at the back, where the cables come out of the OLED displays, wasn't sufficient at all. In fact, I had accidentally made the clearance so small that even the back side of the potentiometer was too big to fit. I had to redesign and reprint the whole main chassis, sadly, which sucked because it's a really big print, and I ended up adding some extra clearance to the bottom of the chassis while also adding the more room at the back that we really needed. Thankfully, the clearance issues I experienced the first time when I tried to assemble the project weren't project breaking and didn't require a revision to be made to the CNC'd parts, as that would really suck. After revising the main chassis though, I was able to relatively easily mount the main plate with its tethered set of OLEDs and potentiometer into the main chassis, while making the barrel jack connections and the USB connection to the main board, of course. So, alright. That was a bit of a struggle, and sadly it required a reprint of the biggest piece of the whole project, but in the end, it's actually gone pretty well. I mounted the main plate to the 3D print using 8 M3x8 countersunk screws, and the small plate went on with a hodgepodge of 2 M3x12 screws, 2 M3x6s, and 2 M3x8 screws in order from left to right. The 2 pairs of screws on the left and towards the middle of the piece were carefully tightened so that they didn't crush the OLED displays against the front panel so hard that they cracked. The 2 screws on the far right are just to mount the CNC to the 3D print though, and those could be tightened without as much care. Once all of that was done, I pressed the knob onto the potentiometer and used some masking tape on the faders to ensure that the fader knobs fit nice and tightly onto them. This will help to ensure that the fader knobs don't get dislodged when being whipped around by the super fast fader motors, as that wouldn't be a nice thing to have happen on your nice mixing desk. I'm imagining flipping through layers and just having the fader caps come flying at your face. And finally, we've got a physically finished build, and holy crap, this thing looks amazing. I think that the form factor is going to be so much better than the originals, and I think that the addition of the new features and better motor drivers will make a world of a difference. That is, once they're actually working. Yeah, right now, this is a whole lot of nothing brick. I need to write the code for this thing, which is my very least favorite part of every project I ever do. But it's critical for the project to actually work, and so I went away for a while to create the firmware that would allow this thing to function. And I'm not really gonna talk about the code because 1, it's long, 2, I don't like it, and 3, it's probably so poorly written that a real developer would have a brain aneurysm looking at it. And so I'm not going to plaster it all over the YouTube video to kill multiple developers. For now, everyone can blissfully download the code and upload it to the Teensy in ignorance, and those who want to read it have been warned. Anyway, while I don't have consistent updates throughout the development of the code, I do want to share one update that I made once I got the PID for all of the faders working, as this is probably my favorite part of the whole project, and I think it came out so well that I just have to share before getting to the finalized version. Alright, I apologize for the bad audio and the sound of my voice. I have to speak quietly because it is late right now, but I just have to film this little update and throw this in the video because I just got the PID stuff working with all 5 faders and saving and recalling presets. I have not done the displays, I have not done the MIDI yet, I've not done the mute buttons yet, I haven't done the knob yet, but I have to give an update on this because it's so cool. So I'm gonna plug power in, and the displays just kind of display junk right now. How cool is that? These are all stored presets that I just throw in here, mostly just to look cool. And man, these faders are zippy. Oh, this thing feels good. That was the hope with V2. Said it would feel good, and I can confidently say that that feels good. And like on this last preset, which is just everything down, to save something completely new, I just do that, and then I hold this for about 1.2 seconds. I'll have an update on the screen when I do that. Like, I'll have the screens display something so that you're not just kind of trusting. But as you can see, now it's saved to there. If I want something different, 1, 2, should be saved now. Yep. Man, this works. So well. I love that so much. That's so cool. All right, here's a real quick comparison. V1 and V2 fader movement. It's not even close. Here, I'll program this with similar-ish presets to the other one. Fifth is that. That says 8. This only has 5, so that's where it ends for this one on the left. Or sorry, the right here. Are we ready? Jeez. Yeah, I think that this thing is so cool. Though I am probably biased, because for me, it's just super satisfying to have successfully fixed the one thing I wasn't happy with in V1 in V2. And I'm also super satisfied that these faders move as well as the ones on several of the nice, real consoles that I've worked on. These faders move almost as fast as the ones on the Midas M32s I've used, and those faders are incredibly fast. It also beats out some of the Allen and Heath boards I've used, and it shreds my PreSonus 32SC's fader movement with ease. So I think that these came out incredibly, and honestly, if and when this project gets pushed to a V3, I'm probably not going to change this aspect of the project at all. But all right, enough about the faders. Let's talk about this thing in action with its full program completed. In the final code, the motion system and preset system didn't change at all compared to the previous demo, though I did tweak the PID values just a tiny bit. And I also added a splash screen that appears across all of the scribble strips to inform you that the system has successfully stored a preset after you've held one of the preset buttons. But when the scribble strips aren't displaying that splash screen, they're displaying the custom names for each channel at the top, and there's a nice spot in the code to edit those. Then there's the mute status of the channel below that, and at the bottom, the level of each channel is displayed as a percentage. The mute buttons illuminate when the mute is active and just send a MIDI command that MIDI Mixer can register and use as a mute command. You just have to add the buttons as buttons in the software, and then add those button controls to each group as the mute control. Finally, the knob is just a 6th fader whose value doesn't change when presets are stored or recalled. And it's also best to be used as a master volume control or something along those lines. However, it can technically be bound to anything, and you could bind your master volume control to a fader instead, and I don't know, music or Discord to the knob if you wanted. And that's all cool, but I know that everyone here wants to actually see this thing in action, so to show this off, I've made another little demo just like I did on the original version. So let's cut over to live me showing off this mixer while actually controlling some audio with it. All right, here's a little demo of this mixing unit. I'm doing this live, and I've got this set up plugged into my computer right now, and I'm going to walk through a little bit of the MIDI mixer setup for this with the mute buttons and stuff. And I'm also going to walk through saving some presets and recalling them and just kind of showing this thing off. So this is based off of the software MIDI Mixer. And I've got it pulled up right here. Right here, I've got a bunch of groups that I've made. And you can assign apps to these groups as well as actual system devices. So like this is my microphone input. So I can put, if I throw my mic input on here, I should be able to control the level of it going into the computer. Now I'm recording things a little bit weirdly, so you won't actually hear that difference. But if I open up Audacity here and I get this going, the mic is completely down. As I bring this up, hopefully we should see, yep, we can see some level in Audacity now. And then if I bring it down again, mutes it. And if I leave it up and then I press the mute button, we should see, yep, completely cuts it from Audacity, then brings it back in. So you could imagine this controlling your mic into, say, Discord or something. And, oh, someone walks into your room, boom. Got your mic muted, no need to worry about actually hitting the button in Discord or hitting some keybind. Nice little physical mute button there, and you can obviously adjust your microphone's volume if you need to be quieter for some reason, or you need to be louder. Pretty sweet. But you can do a lot of stuff with MIDI Mixer. The main thing that you can do, though, is you can throw, like I can throw Apple Music, which is what I use for music, onto the music group. And I can throw Microsoft Edge onto the browser group. I think I need to play a YouTube video here. There we go. Now Microsoft Edge should show up. Yep. I could throw Discord in here if I had Discord open. I don't have it open right now, so I'm not going to use that as a demo. But I can throw Minecraft in the games thing. And like I could throw my whole main system output on the output here. I don't really want to do that because I have stuff set up specially, but it does work and I have tested it. I could put my main system output here onto the main group, and I right now have it set up so that the main group is controlled via this knob on the front panel, which I think is pretty awesome. Like you could have your headphones or your main speakers on this knob as a master volume, and you can have all your faders free for a bunch of other stuff like your mic. And you can see I have mine set up with music, browsers, Discord, games, mic. You can completely change these names and you can completely set up these groups however you want. If you have a completely different subset of software that you want on a group, go for it. And you can just assign faders to these. You put all the faders in as controls, as well as all the mute buttons and the knob as well. And then you could just choose which fader and which mute button controls which group. So in this case, the music group, I have fader 1 named music in the firmware for this, and I want the music group to be controlled by fader 1 and muted with the mute switch. And you can actually see the little OSD on screen display right there. Pretty cool little feature of MIDI Mixer. You can see whether or not it's muted and what the level's at. And so let's get some more audio going so that I can demo this a little more thoroughly. All right, here we go. So I've got a just standard non-copyright song that I use in the background of my videos here. And this is playing in Apple Music. And so in here, Apple Music is on fader 1. And so if I bring this fader up, we should start hearing the music. And we sure do. And I can mute it. I can unmute it at any level. And if it's muted, obviously moving the fader doesn't change anything until I unmute it. So I can set that nice in the background. And then if I say go into my browser and I start playing this YouTube video, I'm using something... I'm using something that is not mine, just so that it's easy to differentiate the voice. And this should play on the browser level. And until I bring this fader up, we hear nothing.
Give yourself a gold star.
But now I can mute and unmute
all the way to
that YouTube video
center in Virginia.
And I can control the level of it.
To work with some of the
mute it, mute the music.
Just how close is too
Let's bring up the game. Should be Minecraft. If I pop into Minecraft here and I punch these pigmen that I've thrown into a pit, you can hear the sound. I'm going to mute that just so I don't use too much of their video in mine. But you can see
I know how I would try to.
I have pretty full control over exactly how loud each part of my computer is. And sometimes the OSD does some weird stuff with MIDI Mixer. That is the only downside to using it, so I am actually going to disable that for now. And so, we still got that YouTube video going. Let's go ahead and build a small mix. Let's say I just want to hear my game mostly. Maybe not quite that loud, maybe around there. And I want to hear my music in the background. And nothing else up. That seems perfectly fine with me. So let's save that as preset 1. So I'm just going to hold the preset 1 button for about 2 seconds, and then when I let it go, lets me know that that was stored. And so if I mute that mix now, if I press this button, it should come straight back to where we were. There we go. Got our game at that level, and our music right where we left it. I can bring like the YouTube video in, and we can save this as preset 2.
We're prepping our 1000
and so now we can switch between preset 1 and 2. Preset 1 does not have the YouTube video in it. Preset 2 does, so that's game, YouTube video, and music.
And in slow motion we can...
And we could maybe make preset 3 just everything down. So now we can easily switch between anything that we want. Say we need to mute the music for a sec, but we don't want to mess up the level. You just use the mute button. Same thing goes with the game. You can obviously edit the mix however you want to.
Tour that included an incredible new makerspace that they use for
and bring it wherever you
Our
need.
supporters on Floatplane get exclusive.
Pretty sweet little thing. I think that's about all that I have to show you. The knob works just like a fader, except it does not get saved and recalled with these presets. And the mutes also are not saved and recalled with the presets. So if you leave something muted, when you switch presets,
flying machines.
it's just unaffected. So right now, both the game and music are muted. And if I switch to
Currently,
the thing that has the browser up, we just hear the browser. We don't hear anything else. Doesn't really matter where we go until we unmute these. We don't hear them. And I chose to do it that way because these buttons are latching. And so even though I could digitally recall the mutes, it would result in some weird behavior if the button was down but the channel was unmuted and it got recalled as unmuted. You'd have to unpress the button and then press it again to get it to mute, which just felt kind of crummy. So I chose to just leave it locked with the physical latching of the buttons. But yeah, that's this project. I'm gonna go ahead and I'm gonna make another preset. This is just music at full volume, and say we want YouTube video at full volume. I'm gonna mute that just so I don't use too much of their stuff. And so there's preset 5. And so we've got music and game here. Music, video, and game.
Constant frame rate. We instead take the 2 samples.
Everything down. Just music.
Samples
And just YouTube
so on
video.
and so.
And this is 8 fully storable and recallable mixes. So you can have up to 8 of these things all at once. And I've got some random stuff stored
They're direct.
in these other ones.
Simple, right?
And so that's the demo of this thing done. I think it came out a lot better than V1. I think it has more features. I think the features came out well. And I gotta say, I'm incredibly pleased with like the fader movement. I think that is just great compared to the previous unit. All right, and back to voiceover me. So yeah, that's V2 of the Motorized-Fader per app volume mixer project. I probably need to come up with a better name for it, but for now, I'm just so happy with how V2 has come out, and I'm really glad that I got all of the feedback I did on the first version. It's thanks to all of your comments and support on that project that I've been able to make it even cooler and better with mute buttons, scribble strips, a better interface, an easier assembly process, and of course, better motion control. It is genuinely all thanks to your support and positive reception of version 1 that I'm able to do a version 2 at all. So if you liked this project, I generally don't ask for this, but maybe leave a like on the video or drop a comment to show your engagement. It genuinely really helps out, and if you want to see a V3 or maybe a miniaturized version of this with 60mm faders instead of the large 100mm ones, I would love to do those projects. I just need to see the support to actually be able to justify it. Well, that's all that I have for you in today's video. I hope that you were able to at least enjoy it and maybe even learn a thing or two. In any case, I hope to see you next time. Goodbye.